Continuing our discussion of multiple choice fall 19 test 3. Everything you need to do question 12 is on the bond association energy table. The easiest radical to make will be the most stable, and the hardest one to make will be the least stable. And we're going to find, I'm just going to categorize these, good review. Primary allylic, vinyl, awful. All my choices must start with 2. You're going to find out with the numbers. Secondary allylic. There's only one right answer. And this is just secondary, garden variety secondary, which is going to be second worst. You can probably not use the table and get the answer now, but the table is our guide. Let's use it because this isn't our question on Wednesday, right? It might not be so straightforward. Primary, I need numbers for all. Let's find them. I'm going to put a number for how much energy it took to make that one, to make this one, to make this one, and to make this one. All positive, right? Because we broke a bond. We're going to our table. I better do, the only reliable way is to do a stop share, start share, and get the table. I thought I had the table open somewhere. I really did. Where, I guess it's that one, and I switched over. I had it, yeah. Primary allylic 360, secondary allylic 357. Primary allylic 360. I am trying to click on it. Plus 360. Plus 357. And vinyl, was that 444? Okay, we're going to verify when we go back. That's 444 for making vinyl, and secondary, I think 402, but I will verify. Secondary, regular secondary, 402, vinyl, 444. Got it. Now I realize time is running out soon. You have to go, I understand, but I will stay after. I have to stop, share, start share. Okay, that was plus 402 to make this one. So the easiest one led to the most stable radical. That's the 357. It will be last. I want the most stable radical last. 357 is taken care of. What's the next lowest number? 360. 1 is second last. It's taken care of. These are less than signs. They look like hockey sticks.
4.
Check. And then 4 is only 402. And as promised, number 2 better be your first because it's the worst. 2413, 2413, 2413, 2413. Yeah, it wasn't bad. Use this reaction to answer 13 through 16. I probably drop this. If this shows up, it'll be 2 questions. Not 4, 2. A lot of you are liking the allylic that's here the best.
Yeah.
This is one where all 3 questions had to be answered from that video. Remember, I charged you with a homework assignment to find a bond association energy question where all 3 questions had to be answered about the first the major product. We did that homework for you. I did. And the night video had all 3 questions involved in your decision-making process, as does this one. So you're not picking any products with HBr. Part 1 for your prediction is pick the fastest HX. HCl is a lot faster, negative 431, than forming HBr, negative 368. Yes, you can use periodic table trends to make the same predictions without numbers.
That's why the BR got on the chain and the CL means HCl.
That is correct. HCl is the driving force. So we like X prime is, X is the CL, X prime is the BR. So we like the CL, therefore X prime equals BR.
And the rate determining step is the slowest step.
We're not there yet. Okay. X prime is BR. There's going to be a reason why we like this product the best. Question 2 was which CH is easiest to break, and the answer to question 2 was this one. Plus 357 is faster than 360. We already did this research. Okay? So that eliminates products where that H is not missing. Okay, gone. Product 2 is still an option. That H, there's only one H on that carbon here. Getting rid of, there's 2 H's now. Getting rid of 1 leaves 1. Product 3 is also, we're down to these 2. Forget about that. Question 3, which HX forms first? Fastest, okay? And what happened here? We got a dot there. Wait a minute. Okay, that's cool. You know how this happened?
What?
That double bond you had to get to this radical to get to this. I hope you see that. But you started with this radical. Okay? And I see that something funky is going on here. There's resonance that stabilizes radicals. That's why radicals are so special. And I see that this gives this radical, which isn't listed for any products, right? So that's not an issue anymore. The issue here is 1, 2, 3, 4, 1, 2, 3. Wait, this is not one of the options at all. That's not one of the options at all. How the heck did you get to this? There's no way to get to that. Here's the resonance option, and that's not a product listed up here. That's just a goofy product, that's all. Here's the double bond moved. And I just want to point out that this product that you get from here is the same as the product you get from here, the direct one. The direct one is this one. There's symmetry here. Oh, maybe they're not. I'm sorry. I think doing this so fast at the end is not making a good video. Long story short, is this thing listed?
This one over
It
here.
is.
Yeah, it is.
It's product 3.
It's the one we like the first.
Yeah, it's product 3. But at least we know how we got there. It's directly from that, which is this. See, this one is this one, giving that, product 3. So we didn't get to the third question. That was a nonsense product. That's the primary allylic one from taking this H. That's nonsense. This is the direct result of this becoming this. And this is the direct result of that one, which is just secondary, right? I don't like that either. And so we got that. Rate determining prop step. This is where this takes time. You got to do the two mechanisms. And the mechanism goes like this. Remember prop 1?
The double bond.
Prop 1. The Cl radical grabs the H. You're asking where Cl radical came from? It's called initiation. We don't use initiation for any energy considerations. It's not a reaction that happens to a great extent. All right, plus HCl. No, that's not this dot. Don't talk and write at the same time. Save you some time. Negative 431. Positive 350. Was it 358? 357. It's the same category. 357. Delta H equals 1 minus 7 is 4. 2 minus 5 is 7. Negative 74 kilojoules per mole. Prop 2. P1, P2. P2, that grabs a BR from BRCL. It is BRCL, I hope, right? Hooking up, hooking up. We have to be experts in this mechanism. It's the only one. I have an announcement about a mechanism in chapter 8 that isn't going to be on the test.
Professor, do we have to do this part?
If you don't know the prop steps, you can't get the right numbers. If you can't tell me which number has a lower delta H, I can't do that. Delta H equals what? We have the plus BRCL. Where do we get that information? You won't see me doing this. I'm going to try BRCL 219. And I believe we broke it. So you will see everything, I hope. I forgot the number, of course. 219. And what about secondary CBR?
Secondary BR is 228.
Secondary CBR allylic, yes, negative 228, right? Negative 228. Once again, it always seems to be bigger minus, smaller minus bigger every time. 8 minus 9 is 9. 1 minus 1 is 0. It's 9, negative. Which is the rate determining step? We finally answered that.
Propagation to
XO equals early. Prop 2 early. That's our answer. Prop 2 early, B. A lot of work. Enthalpy change rate determining step. Thank goodness. Negative 9. Right? Now that work was not wasted time, was it? Enthalpy change overall. Okay, we're not done with that, but we're real darn close. Negative 83. 74, 9. Add them together. Negative 3 kJ per mole. Put an accent on the E, you get mole. All right. Negative 83. Done. And that video's done, I think. Of course, my computer